Uh, Welcome to Indra Tech. We are going to talk about simple values and types of Swift today. Let's begin with what Swift has to offer in terms of type. Usually you have strings, integers, floats as major types and boolean, etc. And in terms of variables, you have either variable as var. You can define variable as var, and then you have a constant that you can define with let. By and large, these are the concepts that apply to every programming language. Whenever you start learning any programming language, you must have a way to explore and express these basic fundamentals into your program, right? For instance, in Python, you may have integer, floats, booleans. For structures, you have list and then hash table like structure called dictionaries in Python. And let's coming back to Swift, you can define any literal. Now coming back to what file we are going to experiment it with, Swift is a compiled language, so you cannot really experiment when you are coding in file and running and compiling and all that. So you need to have a way, something like Jupyter notebooks, again going back to Python, right? You can experiment line by line. And for Swift, you have similar concept called playground, and these playgrounds are part of Xcode. Once you download it on your Mac, you can create file, new, and then new playground file, and I'll show you how to get started with the playground file. So you have this, and if in case you need to experiment with any code, let's see, I'm just typing out literal 3.14, the pi value. I'm going to save and Control Shift Enter. Once I hit Command Shift Enter, it starts. For first time it will take some time in the playground file, but once afterwards, as we will see, you won't take as much time, right? So 3.14, I have hit the play button, or the shortcut is also Command Shift Enter on Mac. You see 3.14, we run it, we got 3.14 at the right. That's the value that we are looking at. Let's try one more, 0.1, and hit Enter, Command Shift Enter. We get the same thing here, right? So it's typically, let's do hello user, Command Shift Enter, right? We get hello user. So you get the idea. On the right pane, you get the output of the program you have written on the left, and that's pretty handy if you want to debug some code function before you introduce into your entire workflow, what it returns, how it returns, if the logic is correct or not, if there are any errors or debug, or all that you can do on your playground, apart from your unit tests, of course, right? So once we do that, now I'm going to introduce you to a variable type, something called var. Whenever you want to define a variable in Swift, it has to start with var. Let's say my city, right? New York. That's the city name. Now what we have done is we have stored the New York string into my city variable. Let's hit Command Shift Enter. We get the value, and we can test it with the print function in Swift. Also we'll do, and on the right side, before we hit Command Shift Enter, you can try to imagine what will be the output. The output will be New York, right? And the \n is basically new line character that every print function appends to your string automatically. All right, so we have, now I'm coming back to a very important concept in Swift called type safety. Swift is a type safe language, right? And for that, what I mean by that, right? So right now, if you look at my city, what type of variable is this? For instance, in Swift, for starters, there are different types of variables. or different types of data that you can store in variable. One is string, other is int, then you have double, then you have floats and whatnot, and boolean. These are by and large your types. What type, if we want to see what type of data this my city variable is storing, you can hit control and click on that. It will show you that var my city is a string, so it's storing a string. Coming back to the conversation that we have started, that Swift is a type safe language. So what do we need to do here is my city. Now once you define my city, it's available for you to reassign, and if I reassign it to Chicago, right, this Chicago is another North American city, not really close by New York, but it's a string value at the end of the day, and you have assigned Chicago to my city. Command Shift Enter. See, you are now seeing Chicago, right? Let's try print as well so that we are keeping our cadence. Command Shift Enter, right? We are now seeing Chicago. So we have reassigned the variable value from New York to Chicago, and we are able to see that it's taking. Now coming back to type safety. Why this is important, right? So let's try and assign value of an integer to my city. Let's pick number 42, right? The secret of all universe. What happens? Cannot assign value of type int to type string, right? That's what it says, and that is what we are talking about when we talk about type safety. Since 42 is an integer and my city is already been declared in the program as a string, you can check it here. This is a string. We cannot assign an integer to a defined string variable. That's a type safety 101. So let's try and assign. Let's go further east. Maybe let's assign Mumbai, right? Coming back to the topic at hand, we have, let's do a number, right? So we have 17, then a double, then you have 17.40. Again, a double is your, I believe, 64-bit integer, and if you can also define a float, which will be a 32-bit integer size of the float type. However, if you're not sure, double is by default and recommended. Default for inference and recommended. Okay, so we have done that. My apologies, this should have been camel case. Command Shift Enter. Oh, see, classic problem. I just defined a number to 17, but I didn't define a type. So I didn't declare a variable, right? So I should have declared a variable, and right. So mistakes happen. It's important to read the error and correct them as they happen. Let's move on to next. There is also something called let in Swift. Let allows you to define constants in your program. So let's try our hand with that. Let year equals 2024, and now we have defined our year as constant, right? Let's do, and it is 2024. It must be an int right now. Let's do it as a string so that we are not introducing any here. So year is 2024, and now let's try to change this year. And this is very important, right? If you have a variable for which the value is going to change in the future, for instance the year, it's not going to be constant throughout the life cycle of your program. Hopefully your program lives more than a year. In that case, you would want this year as non-constant value, something like var, right? But since we have used let, if we try to reassign that value, let's see what happens. I ran the code and it says cannot assign value year to let constant, right? And it also suggests you that change let to var to make it mutable. Right now it's immutable, and sometimes this hint can help you. Sometimes, even though that's the right answer or that may fix the bug, but that may not be what you intended. So it's very important that you read these fixed lines before you apply them. Right now, since we want to change the year, it's safe to change the let to var, and I'll hit fix, and that's about it, right? So we have covered let now. Same thing. Now let's go to the arithmetic operations. So let's do let div is equals to division of two numbers, 2024 divided by 2024. Let's see what it is. It is going to be 1. Now I want to show you one very important thing here. Let's say we want a divide operation equals 20. Let's do maybe 95 by 10. Okay, so since we haven't defined a type for divide operation, and the type of 95 is int, what do you think is the output value of divide operation? Output value and output type, what are your guess? I'm going to hold for 5 seconds. You think, and then we'll move forward. 3, 2, 1. Okay, so let's try and run this code as is and see what we have. You see the value of 95 by 10 comes to 9. This should be decimal because 95 is directly not divisible by 10, right? But that's not the case. Why? Because the inferred type of divide operation variable is int. If you really want that, hey, I want, then let's try defining it as a double and let's see what happens. Again, you can guess what will happen, but we'll try again. Okay, see, it is 9.5. And if you really don't want to define the type of variable, then you need to provide 95 as a double. Simple, right? Even if you do this, you'll get 9.5 and the type of divide operation will be double, right? So those are the very big caveats that you need to think. There is no complete division operator. For instance, in Python, you can do complete division by double forward slashes. That's not the case in Swift. If you just apply on ints and do not define the variable type, you will get the complete division in your variable as output, right? So that same goes with, you have 4 operations by and large. Let's do sum operation and you will get, 3 plus 6. And let's do sum operation equals to 3.0 plus 6.5, right? Let's see what happens. Invalid operation, redeclaration, right? Because we have what did I do? Cannot assign, right? That's what's happening. Let's do some operation 2. Absolutely. All right, so that's about it. If you do 6.0, what does still 6.1? all right, so you get the idea, right? So let me show you what I just did. So if you do right now, this sum operation is inferred as int, but if I do 6.1, it will change it to double. It will be inferred as a double. Okay, same thing goes with multiply operation. You get 3.6, and we will try one more to 6.1, 18 and 18.3. so you get the idea, right? So all these are inferred automatically. Multiplication can be inferred automatically as double. Sum can be inferred automatically as double, but not with divide. Divide is a special case. Divide, subtract operation equals 32 minus 22, and we'll try as usual one more, 2.1. See, this is again int and this is double. So subtract, multiplication, sum can be inferred based on the type of the data. Divide, you need to be a bit more careful. If you really want a decimal division, then you need to either define your integer as double, or you need to define your divide operation variable as a double. Otherwise you will get the whole division only, not the decimal division. All right, moving on to next. Let's move on to the arithmetic operators, right? Another very basic variable type. So you have arithmetic operations in Swift, almost similar as any other logical operators, right? So I'm sorry, these are not arithmetic operators, these are logical operators. So if I do 1 equals 1, try to enter, it's going to be true Boolean value. Then you have 2 is not equal to 1, not equal to 1, you again get true, and so on, right? And then you have and or operations. Let's do and or, right? So let's, and is defined as, and or is defined as, right? So 1 equals to 1, and let's do true. Even I'm not sure what will happen here, but I'm just going to try with you, right? It's going to be true. Then I'll before I go into, so let's do true or false, right? We are using false. What will happen? The output of this will be true. Let's now try a bit more complex things. Let's try 10 is not equal to 11, so the output of this will be true, and 11 is not equal to 12. Again, output of this will be true. So we are expecting a true here. Again, all these are true and false, and or operations are short-circuited, meaning as soon as the for and condition or or condition, as soon as for or condition, if you have a true in the first operand, your output will be immediately returned as true. And if you have a false in your and condition as a first operand, you will be immediately returned as false. And that's how it works in almost every programming language. These are short-circuited operators, right? Let's try not operator, right? So not true, the output is ideally going to be false. I just want to 1 equals to 1, false. There's extra space. Again, this playground is therefore very important to learn Swift, right? Now moving on to some other things. There are tuples in Swift which you can use to store the multiple values of different types. So you can store in tuples like true, this is now Boolean type, then I will store float, then I'll store integer, and then I'll store string, right? And let me try to give you an actual. So my tuple and run. Missed again. I didn't define. All right, so that's, you get the idea for tuples. Important caveat as well, if you want to store the binary operators, you can store binary values or hexadecimal or octal, right? All that can be done. For instance, for binary you need to have 0b as prefix. For octal you need to have 0o as prefix, and for hexadecimal you need to have 0x as a prefix. And finally, I want to leave you with a very important and funny aspect of Swift, is that variables and constants, which are defined by let, right? Variables and constants can have any Unicode characters, and that means not just the values, both values and the declaration. And what I mean by that, right? So if this is my declaration, let's do var, and I want to store the var in an emoji, and if I do smiling emoji, this is valid in Swift, believe it or not. And if I do, this is funny, that's why I kept it the fun for last. Yeah, and if I hit enter, you get that, right? Did I do? Yeah, okay. See, smiling emoji. That's fun. But that's a wrap. Thanks for watching this video. I appreciate your support, and catch you in the next one. Thanks. Bye.